Now let's proceed with the second example. So I'm going to find the Laplace inverse of 3s plus 4 over s minus 2. So multiplied by s squared plus 6s plus 9. So let me erase the highlighter. Oh. Okay, so now this is going to be the equation that we are going to find the Laplace inverse. So how do we know that this is going to be done by using partial fraction? Of course, because of the multiple factors. So if you have like, this is going to be my first factor, this is my second factor, so each of the bracket is being called as a factor. When there is more than one factor, more than one bracket in your function that you're going to Laplace inverse, automatically that is going to be a partial fraction, inversion by partial fraction. And for the first one, so there is no need to worry about this because it's a linear factor. When it is a linear factor, we don't have to check about it being reducible or irreducible. But this one, it is a quadratic factor. So when you come across something that is not linear, automatically you have to check whether it's reducible or irreducible. And for this case, if you plug in the values into your calculator and find the value of the roots, you'll be able to get that this is going to be the case of equal roots, for which the roots is going to be a value of -3. So when you do the factorization, so s squared plus 6s plus 9 is actually equivalent to s plus 3 to the power of 2. So that will be the outcome, right? So therefore, when I wanted to decompose this in terms of partial fraction, so what the function that I'm looking for is going to be 3s plus 4 over, so I'm going to have s minus 2 multiplied by s plus 3 to the power of 2. So here, from what we have from the power outside the bracket, straight away we can tell. So the fact that here I'm going to end up with 3 partial fractions. And the first one is going to be something over s minus 2. And then I'm going to have a function over s plus 3. And the last one is going to be over s plus 3 to the power of 2. And because all of this s inside the bracket, so this is actually a bracket to the power of 1, so the s inside the bracket is raised to the power of 1, automatically will end up with a constant a, b, and c at the top. Right, so now I want you to bear in mind that when we wanted to equate the denominator, because the next step is we wanted to make the denominator equal. So on this side, it's going to be over s minus 2 multiplied by s plus 3 square. So on this side also, we're going to make it over s minus 2 multiplied by s plus 3 square. So please bear in mind that it is not always the case of cross multiplication. For the previous one that we had, yes, it's going to be cross multiplication because it's only 2 of them. So a is going to be multiplied by this, b is going to be multiplied by that in order to make the denominator equal. But that is not always the case, especially when you have like 3, 4 fractions and so on. Okay, let me give you the idea. The idea is going to be something like this. For example, let's say if I have 3 fractions, 1 over 2 plus 1 over 4 plus 2 over 12. And I'm going to make the whole thing over 12. So what I'm going to do is that I'm going to multiply the numerator and the denominator, for which my aim is that so that the denominator will achieve a value of 12. So for this case, for the first one, I'm going to have multiplied the top and bottom by 6. So that is why I'm going to have 1 multiplied by 6. So that is going to be a 6 from the first fraction, plus for the middle fraction, I'm going to have to multiply top and bottom by 3, and that's going to be 6 plus 3. And the last one, because it's already over 12, so that is simply going to be plus 2. So this is actually going to be the concept that we are going to apply up here, right? So that is why for the case of A, so A already has s minus 2. So if I want to make this as the denominator, so I simply have to multiply A by s plus 3 to the power of 2. And for the case of B, so B already has 1 s plus 3. So I need to multiply that by another s minus 2 and another one of s plus 3, so that it becomes s plus 3 square. And for the case of C, C already has s plus 3 square, so I only have to multiply that by s minus 2. So now that the numerator is the same, the denominator is the same, the numerator must also be the same. So let me copy it down here. So the equation that we're going to use is going to be 3s plus 4 is going to equal a multiplied by s plus 3 square. So plus b multiplied by s minus 2s plus 3, and the last one is going to be c multiplied by s minus 2. So this is going to be the equation that we're going to use in order to find the value of the constant a, b, and c. And all we have to do is, I'm going to use substitution. So I'm going to substitute all the value of s in the equation and figure out what is going to be the value of the constant. Okay, so remember I mentioned to you in the previous video the fact that we can only, when we use substitution, we can only find the value of s to substitute from the linear factor. And here I have two linear factor. So the first one is s plus 3 and the second one is s minus 2. And this is just the repetition of the two linear factors. And from s plus 3, I would be able to find my first value to substitute. So that is s plus 3 equals 0. S is going to equal negative of 3. So now everywhere there is s in the equation, that will be substituted by a constant of negative 3. So I'm going to have 3 multiplied by negative 3 plus 4 is going to equal a. So when I substitute negative 3 in here, I'm going to have negative 3 plus 3. So that is going to be a 0. So that is why I don't need the a. So a is going to be 0. And for the case of b, again, when I substitute the fact that s is going to equal negative 3 plus 3, so that term over here is going to be 0 as well. So therefore, I'll end up with only the last term, which is c. So I'm going to have c multiplied by negative 3 minus 2. So when I simplify, this is going to be negative 9 plus 4, which is a negative of 5. And on this side, I have negative 5 of c. My c value, that is going to equal 1. So that is going to be my first constant value. And then I'm going to find the second constant value. Again, if I were to use this linear constant right here, s minus 2 equals 0. So that will be the case when s is equal 2. So therefore now, everywhere there is s, I'm going to substitute the value of 2. So I will have 3 multiplied by 2 plus 4, and that is going to equal a multiplied by 2 plus 3 to the power of 2. So the middle term, because of this, is going to be 0, and because of this is going to be 0 as well. So therefore, when I simplify, I'll get a 10 on this side is going to equal 25 of a, so that's 5 square. So my a value is going to equal 10 over 25, or that is basically going to be 2 over 5. So that is going to be the second constant value. So here I have 3 values to find, so which are going to be a, b, and c. I already have my c value. I already have my a by using these two values right there. So the next thing is that I still have to find another one constant, which is going to be b. But the thing is that we run out of linear factors because we only have 2 linear factors. We can only get 2 values. So how do we find the other values? Okay, let's prove here, run out of values to substitute. Okay, so when you have no more values to substitute, what you can do is you can choose any value. Okay, but the rule is that, so you're going to choose any value, so preferably a small and positive value. So why does it have to be small? Because you don't want to end up with like having to simplify a big number. And why is it has to be positive? Because you don't want to be dealing with negative numbers, because when you deal with negative numbers, so the chance for you to make mistakes are going to be higher. So therefore, pick a very small and a positive number. So what do I mean by small positive number? Like for me, like my number one preference would be a number of 0. 0 is very easy to just substitute. Anything added or minus by 0 is going to be the value itself, right? So you're going to choose a value of 0, 1, 2, 3, and so on. So pick a very small and a positive number. And for this case, because I haven't used 0, so pick a value that you haven't used. So for this case, I can pick 0, I can pick 1, but I cannot pick 2 because 2 is already here, right? So do not use 2. So therefore, for this particular one, I'm going to use s equal 0. So that is going to be the tip value that I'm going to substitute. So everywhere there is s in the equation, so I'm going to substitute a 0. So my equation is going to end up like this. I'm going to have 3 multiplied by 0 plus 4. So that is going to be a 4. And then I'm going to have a 0 plus 3 to the power of 2. So plus b multiplied by 0 minus 2, 0 plus 3, and the last one is going to be c multiplied by 0 minus 2. So let's simplify this. On this side I'll end up with a 4, and on this side I'll end up with 9a, but I already know the value of a. The value of a from our calculation is equal to 5th, 2 over 5. And then I have a negative 6 of b, which I don't know the value, so leave it as b. And then I'm going to have negative 2c, and I know that my c value is going to equal 1. So let me rearrange this. So 6b is going to equal 18 over 5. So that is going to be minus 2 minus 4. So which is going to be 18 minus 6 multiplied by 5. That's a 30 over 5. So which is going to be negative 12 over 5. So from here, so you can simply use your calculator for this. So I'm doing it on the screen. So I'm doing it by hand. So my b value is going to equal negative 2 over 5. So I divide this by 6. Okay. So that is going to be my t value, which is going to equal b over negative 2 over 5. So even if you substitute a value of not 0, so either you substitute a 1 or a 3 or a 4 or a 5, you will still end up with the same value of b equal negative 2 over 5. So the value that you're going to pick, so that is totally up to you. Alright, so now that we are at this stage, so now I'm going to start substituting back into my partial fraction. So what we wanted to find is going to be the Laplace inverse of a. Okay, so this is my partial fraction. I'm going to substitute my value of a, b, and c in here. So my a value, so that is going to equal to 5th. So I'm going to have 2 over 5. So let me write that smaller. So I'm going to have 2 over 5 over s minus 2. That's the first value. Plus b. My b value is negative 2/5 over s plus 3. And my c value just now is going to be 1. So I'm going to have 1 over s plus 3 square. So this is going to be the equation that I'm going to inverse. So we start with an equation that is very complicated that we couldn't inverse, and we end up with 3 fractions that is smaller and easier to inverse. Okay, let's start with the first one. So I have this over here, 2 over 5. I know it's going to be exponential because I have s to the power of 1 accompanied by a constant. So that will be 2 over 5 exponential of 2t. And the second term is going to be negative 2 over 5. But now because of the plus, I'm going to have exponential of negative 3t. However, please be very careful. For this one, so you cannot use the table because we don't have anything in the table that looks like this, and this is not equal to s square plus 3 square. No, they are not equal because s plus 3 square is actually s square plus 6s plus 9. So therefore, there's no way that we can actually use the table to find the inverse of this. So let me put a remark. Any terms that cannot be inverted by using the table is definitely will be done by using inversion of Fishev theorem. So my IFS stands for inversion of Fishev. Okay, so that is why the last term is going to be inversion of Fishev. So let me add a page over here. Okay, so therefore now let me do the calculation over here. So I'm going to find what is the Laplace inverse of 1 over s plus 3 square by using inversion of Fishev theorem. So let me remind you about inversion of Fishev theorem. The theorem states that if I have a Laplace inverse of f of s plus a in the denominator, that is going to equal exponential of negative at multiplied by f of t. And for this case, my a value, this is going to equal s plus a, that's a 3. So my f of s plus 3 is going to equal 1 over s plus 3 square. That has to be changed to f of s. And this is going to be achieved when I have everywhere that is s, I'm going to minus 3. which is referring to the term in the denominator. So I'm going to have 1 over s minus 3 plus 3 square, so which is going to be simplified to 1 over s square. So when I Laplace inverse, I will get that f of t is going to equal t. So therefore, when we put this together, so we know that the Laplace inverse of 1 over s plus 3 square is going to equal exponential of negative at, which is negative 3t for this case, and multiplied by t. So I'm going to write over here, so using the inversion of a shift theorem, and this is going to equal exponential of negative 3t multiplied by t. So that will be the outcome. So that is going to be the end of the calculation. So that is for our second example. So this is going to be the third example. Let me clean this first. Okay, so the third example, I'm going to find the Laplace inverse of s squared plus 2s plus 25 over s plus 5 multiplied by s squared plus 2s plus 5. So that is a difference at the top and the bottom. They are not the same. So at the top, this is 25, but this is a 5, so you cannot cancel them. So if you think that you already got the idea by now, you don't have to watch this. But if you decide that you have to see more on partial fraction, then keep watching example number 3. Alright, so now let's start with this. Again, so this is a linear factor, no need to bother with that, but this is not linear, so you have to check. And if you use your calculator and find the roots, you will find that this is going to be an irreducible function. So I'm going to have s squared plus 2s plus 25, and that is over s plus 5 multiplied by s squared plus 2s plus 5. How many fractions will you end up with? So it's going to be 2 of them, to the power of 1 to the power of 1. So I'm going to have the first one is going to be over s plus 5, and the second one is going to be over our irreducible function of s squared plus 2s plus 5. And regarding what goes on top, this is to the power of 1, so I'm going to have this is to the power of 2, so I'm going to have bs plus c. And sometimes you can also write it as b plus cs, so either way is correct, it doesn't matter. But if you write it this way, then your value of b and c with mine, it's going to be the other way around. But both of them are correct, no need to worry about that. Okay, so now let's start making the denominator equal. We know that this is just cross multiplication because there's only 2 fractions. So I know that the equation that I'm going to use is going to be s squared plus 2s plus 25. That is going to equal a multiplied by s squared plus 2s plus 5 plus, I'm going to use a square bracket so that you don't miss out that with my c, and then this is going to be multiplied by s plus 5. Okay, again, as I mentioned to you before, you can only find values to substitute from the linear factor, and here I only have one linear factor, which is going to be s plus 5. So that's why. So I'm going to use substitution, and my first substitution is going to be s is going to equal negative of 5. When I substitute s equal negative 5, so I'm going to have negative 5 square plus 2 multiplied by negative 5 plus 25. And on this side, I'm going to have a. There's going to be negative 5 square plus 2 multiplied by negative 5 and plus 5. Now let's simplify this. So there's going to be 25 minus 10. So that is going to be a 4t. And on this side, I'm going to have 25 minus 10. That's going to be a 15. Plus 5, that is going to be a 20. So I'm going to have 20a. So I got my first constant value, that a is going to equal 4t over 20. So that is going to equal a value of 2. So my first value is going to equal 2, a equal 2. Alright, so now that I already have the value of a, I'm going to find the value of b and also c. So you have 2 choices here, how to find the value of b and c. So the first choice is that you pick any value. Like what I did before, I picked 0. Okay, so you can pick any value, and then you'll end up with a simultaneous equation. Okay, and from that you're going to find what is going to be the value of b and also c. So that is one way. So the second way is that instead of like picking any value, so what you can do also is that you can also use the other method that I've shown you before, which is going to be comparison. So if you ask me which method do I prefer, I would say I prefer method comparison, because when you choose method number one, there's a very high chance for you that you're going to do a mistake while you were substituting the values, the simultaneous equation, and so on. So that is going to be quite a long process. So the longer the process is, the higher the chance that you're going to do the mistake. So therefore, in order to minimize that, I'm going to use comparison instead. Okay, now I need to find the value. I already have A. I need to find the value of B. Okay, first of all, if I were to expand this, actually you don't really have to expand. So from here, right away I can tell. So I'm going to start comparing those with s to the power of 2. And from here I can tell that this is when I expand, I'm going to have as square. And this 2, when I multiply, this is going to be b as square. So that is going to like the only two terms that is going to be in term of s square. Like you can expand them if they are as simple as this. This is going to be just 2as plus 5a. And this is going to be bs square plus 5bs plus cs plus 5c. But what if like you come across something that is like super complicated? Then there is no way that you can actually expand them. So usually I don't expand them. So I just eye them, I have a look at them and decide instinctively, like, so this is going to be s square. If I were to expand, this is going to be s to the power of 1, and so on. Alright, so upon comparing the s to the power of 2, so on this side, my coefficient is given by a value of 1. So I'm going to have 1 is going to equal. On this side, I'm going to have two coefficients of s square. So which is going to be a plus b. And because I already know that a is going to equal 2, so I will get that b is going to equal 1 minus a, which is going to equal 1 minus 2. So b is going to equal negative of 1. So that is going to be my second constant value. And now I need c. And I know that this is my c, right? So instead of choosing those with s to the power of 1, there's going to be 3 terms. I'm going to minimize that. I'm going to choose the one with s to the power of 0. On this side, I'm going to have a 25. And on the other side is simply going to equal 5a plus 5c. Okay, I can actually simplify this equation. I can write that 5 is going to equal a plus c, right? And from here, I'm going to have c is going to equal 5 minus a. My a value is equal to 5 minus 2. So I'll get that value of c that is going to equal 3. So now I already have all my 3 values, a, b, and c. So I can substitute back. So I'm going to find the Laplace inverse of a, so which is going to equal 2. So I'm going to have 2 over s plus 5 plus, and my b value, that is going to equal negative 1. So I'm going to have negative 1s, because I put b as just now, plus c. That is going to equal plus 3, and that is going to be over s squared plus 2s plus 5. Okay, so this is going to be a bit more complicated than one that we have seen before, but the idea is still going to be the same. So whatever that is possible to be inverted by using the table, which is the first one, is simply going to be 2 exponential of negative 5t. This is definitely not possible to be done by using the table, but we know that anything that cannot be done by using the table is going to be inversion of a shift theorem. So this is inversion of a shift theorem. So let's do the calculation underneath. No, not you. Rotate counterclockwise. Yeah, this is what I want to rotate. Okay. Inversion of a shift theorem. So I'm going to find the Laplace inverse of negative s plus 3, and that will be over s squared plus 2s plus 5. So we have come across something that is similar before. First of all, from here we cannot identify the value of a, and in order to do that we have to do completing the square, for which this is actually Laplace inverse of negative s plus 3 over, underneath I'm going to have s plus 1 square. So this is going to be s squared plus 2s plus 1, but I don't need a 1, I need a 5, so this is going to be plus 4. Okay, so I've shown you in the first video about this, the first part, how to do completing the square. Alright, so now that I have this information, I can start writing the fact that my a value is going to equal 1, my f of s plus 1. Remember, these two, they matches. This s plus 1 is going to be s plus 1 as well. So I'm going to have negative s plus 3 is going to be over s plus 1 square plus 4. I'll be converting this to f of s. So what I have to do for this case is going to be minus 1. So everywhere there is s, I'm going to put s minus 1 instead. So this is going to be negative. So put the negative outside and bracket around, then only is going to be s minus 1 plus 3 is going to be over, and then I'm going to have s minus 1 plus 1 square plus 4, and this is going to simplify to negative s plus 4, and that will be over s square plus 4. And my function f of t is going to equal a Laplace inverse of two functions. The first one is going to be negative s over s square plus 4, and the second one is going to be 4 over s square plus 4. So we just what do you call that, you just separate them. Okay, so then here, because of s at the top, I know what this is going to be. So 4 is actually 2 to the power of 2. This is going to be negative cos of 2t. So that will be the first term. And the second term, again, my a value is going to equal 2. I need 2 at the top, so I'm going to multiply this by 2 over 2, and therefore 4 divided by 2, that is going to be a 2. I'll end up with 2 sine of 2t. So I don't explain this in detail because I have talked a lot about this during the inversion of the elementary function 3.3.1 if I'm not mistaken. So refer back to that. Okay, so therefore here, when I put together according to the formula, so I'm going to have plus exponential of negative a, so it's going to be exponential of negative t, and my function f of t just now is equal negative cos of 2t plus 2 sine of 2t. So that will be the outcome. So instead of like writing therefore the Laplace inverse, so I simply combine them here. So that is going to be my exponential and my function f of t. So that will be the final outcome. Okay, so please be what to call that. So this is a very common thing in partial fraction that you're going to come across something like this. It is very common that when you do partial fraction at the end, so there will be certain terms that has to be inverted by using first shift theorem. And please, I do not encourage you to right away over here you separate this into two functions. No, because you will end up doing the inversion of first shift twice, and you don't want that. So simply put them together and do this calculation, and you will get both of the terms right away. It's better that way. Okay, so that's it for inversion using